So how to translate our solution set to be matrices format using eigenvalue and eigenvectors? We already derived that very important equation for eigenvalue and eigenvector. So eigenvalue, eigenvector, matrices format, which is A T equals to T D. And based on this equations, you can say the T inverse A T equals to D. Okay, so both left and right hand side, you can just times the T inverse. So T inverse AT will be T inverse T, which is identity times the diagonal will be itself. So we can rewrite this also A will be equals to, you can times T, then it will be identity times AT. So T, D, T inverse, that will be your matrices A. And if you have A squared, that will be T, D, T inverse, T, D, T inverse. And you know this one will be identity. This D times the D, which is diagonal, will be D squared. So it will be T, D squared, T inverse. Then you will have A to the third, will be T, D to the third, T inverse. You have A to the N, dot, 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 until A to the N, will be T, D to the N, T inverse. Okay. That is our, you just do some simple multiplications on the eigenvalue and the eigenvector matrices format. And recall to our previous dynamic system that X equals to A times X, right? And our solution format is X to the T, E to the A, T, X initial. Okay, and this E to the AT, this E to the AT, this is an exponential format where this A is either uncoupled or coupled dynamics. We can use Taylor expansion to expand this exponential to be a polynomial format, which is identity, the identity matrix plus AT plus half of A squared, T squared plus 1 to the 3 factorial, A cube, T to the cube, and plus dot, dot, dot. And we already derived the simple multiplication of A squared, A third to the A n's. Then we can just replace the A squared, A third to A n's with the transformative matrix and the diagonal matrix. Okay, so the identity matrix will be T inverse, TT inverse. The A will be TDT inverse. So it's T, D, T inverse times the independent variables plus half of the T, D squared T inverse. So T, D, T inverse T squared plus 1 over 3 factorial T, D to the cube, T inverse, T to the third. Okay, and you can dot dot until the AN's part. Okay, and what that tells us will be equals to, we put all the T on the left. Okay, so T all the term have this T term will be equals to identity matrix, because that is just itself, identity matrix, plus dt plus half of d squared, t squared plus 1 to the 3 factorial, d cube, t cube plus dot dot dot. And then all the term have the T inverse, so we put T inverse outside of the paralysis also. So what we got here is identity plus dt plus half of d squared t squared plus 1 over 3 d cube t cube. And you found that this is an exponential function as well, represented by the Taylor expansion, which is t times the inside will be exponential of dt times t inverse. So this is how that eigenvalue and the eigenvector matrices can transform this coupled dynamics into uncoupled dynamics with the eigenvalue, eigenvectors matrices. So the e to the at, if this is coupled, then it will be t times e to the dt times t inverse, and this t will be constructed with all the eigenvectors. Okay, this is very important. Very important. So e to the at will be equals to t times e to the dt times t inverse. Very important to decouple the dynamics into uncoupled dynamics. Important.